Welcome all in today's lecture. I'm Virat Pandey, and in today's lecture we're gonna solve a question which is the train and the wagon problem. So in the train and the wagon problem, we will face a problem which is related to a train and the wagons. So let's see the question. What the question is? So in the question, train, 8,000 kg engine pulls a train of 5 wagons each of 2,000 kg. So we'll mark the important points also. So here a 8,000 kg engine pulls a train of 5 wagons, each of 2,000 kg, along a horizontal track. If the engine exerts a force of 40,000 Newton and the track offers a friction of 5,000 Newton, then we have to calculate the net accelerating force and the acceleration of the train and the force of wagon 1 on wagon 2. So the diagram looks like this. You can see here, these are the wagons, right? So here this is the engine, first wagon, second wagon, third, fourth and fifth. Now in the question it is said they are moving in the horizontal track, and the thing is that a 8,000 kg engine, the engine is of 8,000 kg. The engine weighs 8,000 kg and pulls up 5 wagons. There are 5 wagons of 2,000 kg. So each wagon is of 2,000 kg, right? And they are moving in a horizontal track. If the engine exerts a force of 40,000 Newton and the track offers a friction of, so the friction here is 5,000 Newton, right? Okay, let's find these all three things, right? So let's move on to the question. The question is pretty simple. In the question, we have to calculate the net accelerating force. So at the net accelerating force, you can see force is equals to force of engine. If we have to find the net accelerating force, it will be equals to force of engine minus force of friction, which will be equals to 4,000 Newton, and force of friction was 5,000 Newton, which will be equals to 35,000 Newton. So here the net accelerating force is 35,000 Newton. After this, we have to calculate the acceleration of the train. We have found the net accelerating force. Now we have to find the acceleration of the train. So to find the acceleration of the train, we should know that we have just calculated that the net force exerted by the engine on the train is 35,000 Newton. Now the mass of one wagon of train is 2,000 kg. So the mass of 5 wagons of train will be 2,000 into 5, which will be equals to 10,000 kg. In other words, the mass of whole train is 10,000 kg. So here we can see that mass of train is 10,000 kg. Now then, finding the acceleration of the train, as we know, the formula is the net force is equals to mass of train into acceleration. How we found that? Force is equals to mass into acceleration. There is a formula, force is equals to mass into acceleration. So applying this formula, we will get force is 35,000 Newton, which will be equals to mass will be 1,000 into acceleration will be a. So acceleration will be 35,000 upon 10,000 meter per second square. Therefore the acceleration is 3.5 meter per second square. After this, the calculation of force of wagon 1 on wagon 2. So there are 5 wagons behind the engine which have been marked 1, 2, 3, 4, 5 and 5 in the figure. this in the figure we can see. So here force of wagon 1 will be equals to that we have above, but there are only 4 wagons behind wagon 1. Now force of wagon 1 on wagon 2 will be equals to mass of 4 wagons, because it is behind wagon 1, into acceleration of the train. Applying this pretty formula, we will get 2000 into 4 into 3.5. So the answer will be 28,000 Newton. So the force of wagon 1 on wagon 2 will be 28,000 Newton. Thus the force of wagon 1 on wagon 2 is 28,000 Newton. And we can see here is that in the question we have to find that force of wagon 1 on wagon 2. Here the question was pretty simple, but when it says that we have to find that there are 5 wagons, right? We have seen there are 5 wagons, one engine moving on a horizontal track. That makes it logical, because it was saying to find the force of wagon 1 on wagon 2. So how we will calculate? First we will calculate this, after we will get a value of one thing, putting it on this, then after this we will find the third also. So one by one we can find all 3 of them. So it is easy, right? So we have found that calculation of the net accelerating force, calculating the acceleration of the train, calculation of force of wagon 1 on wagon 2, and thus the force of wagon 1 on wagon 2 is 28,000 Newton.